Go 1.18 introduces fuzzing to the Go testing ecosystem. Fuzz tests look a little bit like this. Looks strange, right? Hi, my name is Wani Bryson. Today we're going to learn how fuzzing works so that we can use it to search for hard to find defects in our Go code. First, we're going to write a byte averaging function. Then we're going to write a fuzz test around that byte averaging function. And then finally, we're going to use the fuzz tools to see if we can find any defects within the function that we wrote. So let's start by creating a new package with go mod init, and I'm going to call this tutorial/fuzzer. And then we're going to create a file called fuzzer_test.go and give it the package name fuzzer. Next, I want to define a function to test, and I'll call this average bytes. And it's going to take an input byte list, which we're going to average into an integer. Inside here, we'll start with an integer sum at 0, and then for each value in the range of our input list, we're going to increment the sum by the value cast as an integer. Finally, we're going to return the sum divided by the length of the input slice. Next, we're going to write a fuzz test. Fuzz tests are functions which start with the word fuzz and takes a testing.f argument. So in the code, I'm going to define func fuzz_average bytes, and it's going to take this f testing.f argument. Next, we're going to add what is called a seed corpus, which are basically input arguments to our fuzz test. These are also used as the seed for generating other randomized inputs for fuzz testing. So we can do this by using f.add, and in this case, I'm going to go with a byte list of 1, 2, 3. We can add more seed corpuses if we want, and it's actually quite a good idea if we want some kind of regression testing. In this case, we're just going to keep it at 1. Now we'll call f.fuzz, which takes a function with inputs of testing.t and the inputs to our seed corpus. Inside this function, I'm going to call result is equal to average bytes with our input argument a, and then I'm going to add a check. If result is less than 0, then we're going to call t.fail. And this is basically because all of our inputs are bytes, so we know that a negative result is incorrect. Generally, we need to keep the requirements for our fuzz test quite loose because the inputs are randomized. Now let's jump into the terminal. We can run go test as usual, and that works fine. But to run fuzzing, we use go test with the fuzz flag, and we make that equal to dot. And it catches a failure and then creates something called the generated corpus, which we can look at up here. When we open up the generated corpus, we can see that the failing test input was this empty byte array. We can then confirm this by looking at the output of the fuzz testing, which shows a panic here, integer divide by 0. And the divide by 0 is caused by taking the length of the empty array. The generated corpus also acts as a regression test. So if we jump back into the terminal and run go test, then we can see that it still fails because it's not only loading our seed corpus, but also this generated corpus as well. So that's pretty helpful. Let's go fix the average bytes function. Jumping back into the function here, I'm going to add a check. If the length of in is equal to 0, then I'm just going to return 0. And if we save this and jump back into the terminal, we can run go test once more. And our regression test pass, so let's try using go test with the fuzz flag again. And the fuzz test will actually run indefinitely until it either catches a failure or it panics. In this particular case, it's not going to panic anymore, so this would actually run forever, which isn't particularly useful for CI, so I'll show you a quick trick if you want to automate your tests. Now I'm going to run go test with the fuzz flag, but also with a fuzz time flag, and I'm going to set this to 5 seconds, which will limit the execution time of our fuzz testing to only 5 seconds, which is really good when we want to run fuzz testing in some kind of CI environment where we don't want it to run forever. Fuzzing is an interesting tool for our Go testing toolbar to help us discover hard to find bugs. I've been Wani Bryson, happy testing, and I'll see you later.